All right, A&P1 students, this video we're going to kind of focus in on just one of our objectives, learning objectives for Chapter 2, and it's the octet rule. So down here I have the definition or what the octet rule means and as it applies to our atoms. So the octet rule is this general rule. There's some exceptions, but general it works for a lot of the atoms that we're talking about in the human body. But the octet rule is that tendency for atoms to maintain an outer electron shell with 8 electrons. So if you remember, we said that our atoms are neutral in that they have an equal number of protons and electrons. So if those are the same, they're in balance, and then we don't get a charge for the atom. So now when it comes to the octet rule is there to help us predict how atoms are going to form chemical bonds with each other, how they're going to react with each other. So realize we've kind of just been focused on atoms, single atoms like carbon and sodium, but realize in the human body and in nature they will react with each other, and so this kind of tells you kind of why they have that tendency to react with each other. So this octet rule helps us predict. We'd like, scientists have observed these atoms in the human body and in the environment and notice that they have this tendency to always try to keep 8 electrons in their outer electron shell. So I'm going to show some pictures to help you visualize this, kind of understand it a little bit better. And so I'm just going to use some of our atoms that we've already been talking about. And there we go. All right, so we'll do carbon. So this is one of those models that we use to show an atom. And you will just recall that from the previous video, we talked about these being, they called them energy shells or electron shells or electron orbitals. So I'm going to kind of stick with electron shells for this video. So we have this one here, the one that's closest. This would be, in this case for carbon, this would be the innermost electron shell. And then we have the outermost electron shell. Okay, so whenever electrons, how they position around the nucleus is there's enough room in this innermost electron shell for 2 electrons to be there. So each one of those is an electron, and it's orbiting around this nucleus in this plane here. But there's not enough room here to get any more electrons in there. This is not a very large area, so only 2 are in there. So we call this innermost electron shell here, we call it full with 2. So that goes with all atoms. If there's 2 electrons in this innermost shell, then we consider that full. All right, and with carbon though, carbon has more than just 2 electrons, so it has 6. So in the outermost electron shell, that's where the other 4 are going to go. So they're placed here. All right, and so remember this is an atom that has a neutral charge. So we have 6 electrons here. That means we have 6 protons in here. And neutrons are commonly the same number too, 6. So that keeps this neutral with no charge. But what we've noticed is that these particular atoms that are in the body and in nature, they will want they have a tendency to want to keep this outermost electron shell full. And when it's full with 8, they call that an octet. So that's kind of where that name octet came from. And you probably are familiar with that octet prefix that means 8. So whenever those electrons, there's 8 of them in that outer electron shell, they have an octet, And then they have a tendency to want to do that because that makes them more stable. So they say they gain chemical stability. So they're kind of, when they're in our human bodies or in nature, they're always kind of looking for other atoms, electrons that they can bond with or interact with, so that they can try to get 8 electrons in their outermost electron shell. So that's how it's kind of predicting how they're going to form chemical bonds, is based on, how many electrons they have in that outer electron shell. So if we had, this is not this one, but if we had an atom that already had 8 electrons in its outer electron shell, then it would be chemically stable, and so it wouldn't want to form bonds with any other atoms. But those aren't ones that we study a lot in the human body, aren't as important when we're talking about anatomy and physiology. So, okay, so that was for carbon. And then I have a sodium atom here. And these pictures were all kind of not from the same source, so they might look a little bit different. But so again, this is the nucleus with the protons and neutrons, but we're going to count the electrons here. This one, sodium, actually has 3 electron shells. The innermost one, you'll notice, has this electron and that electron, so it's full. And then the second, or middle electron shell, if you count those, there's 8 electrons in there. So, and then once you get 8, that's full. But in this case, sodium has an additional electron. So it has 11 electrons. So that last electron is going to be in the outermost electron shell. And remember that the sodium wants to go and find another atom to react with in order to, oops, my little pointer, there we go, in order to get 8 electrons in its outermost electron shell. So it's not feeling very chemically stable at this point. So sodium will react with other atoms in order to regain chemical stability, or gain chemical stability. So, and we're going to talk in the next video about, the chemical bonds that happen to make, sodium chemically stable or allow sodium to meet that octet rule and maintain 8 electrons in its outermost electron shell. All right, oxygen atom, this is another one, protons and neutrons in the center. The innermost one, 2, means that it's full. But this oxygen atom is going to have 6 more electrons, and they'll fill in the outermost electron shell. So this has 6, and so it wants 2 more electrons. And again, it can't, make new electrons, so it has to go find an atom, another atom that has electrons that it can share with it, or maybe sometimes they'll donate an electron to another atom, or gain, or take another electron from another atom in order to keep their outermost electron shell at 8. Nitrogen, protons, neutrons in the nucleus. Innermost one has 2, so it's full. But then we have these additional electrons that are going to fill in the outermost. And again, it doesn't. It's only 5, so nitrogen's going to want to look for 3 more electrons to fill in here. And then chloride atom. This one's got quite a few. They put the numbers down on this picture. So the innermost electron shell's got 2, which means it's full. The second one's got the full 8. And then the outermost electron shell is almost full, but not quite. It needs 1 more electron. So it is not chemically stable. So it'll be going looking for another electron. In this case, probably what it would want to do is, just take an electron from another atom, and that way it could then have 8 in its outer electron shell. All right, now the hydrogen atom, I couldn't find a great picture of this one, but realize the hydrogen atom, it has one proton and one electron. And so this is kind of a little bit of an exception, but since hydrogen is one of those most abundant elements in the body, we should know that it also wants to, just like the other atoms, wants to gain chemical stability. But it only has one electron. And remember in those other pictures I was saying how if you have that innermost electron shell, it can only hold 2 electrons because it's not, it's really close to the nucleus where the protons and neutrons are. So what the hydrogen atom would want to do is just try to find another atom that it could share an electron with or get an electron from. So that way it can have 2, which means it's full. So this not technically goes along with the octet rule because there's not 8 in this area, but we know that 2 is how many electrons that can fit, and that causes that atom to be chemically stable. So there's a little bit of a exception to the octet rule for the hydrogen one. All right. Okay, so that is our, I'm gonna find out, there we go. That is for, I'm going to go to our objectives because I didn't do that at the beginning. That was for our 5th learning objective, state the octet rule, and I kind of stated it, but then kind of explained it a little bit more because just stating it doesn't really generally help students understand what that rule means. So in the next video, then we will start talking about these things that are formed, the bonds that are formed, and the what we start calling those atoms after they start gaining chemical stability by trying to, get 8 electrons in their outer electron shell. So, all right, so that's our octet rule, and I'll see you in the next video.